Welcome to Unit 2, Lesson 18. This is going to begin the second half of our Unit 2, and the test will be on December 1st. This lesson is titled Representing Situations with Inequalities. So up to this point, we have concentrated on equations, anything with an equal symbol in it, where we stated that whatever was on the left side was equal to whatever was on the right side. Well, now we're going to start looking at inequalities. In this lesson, we're going to use inequalities to represent constraints in different situations. You have one learning target for this lesson, and that is to be able to write inequalities that represent the constraints in a situation. So if by the end of the lesson you do not feel comfortable saying that you can do that, then that is what you need to come ask me questions about and get clarification on before we take our test on December 1st. So our warm-up today is 5 minutes, 18.1, titled, What Do These Symbols Mean? Number 1, match each inequality to the meaning of a symbol within it. So now instead of having equal symbols in between, we're going to start having these inequalities. And one thing you want to understand is that we are reading from left to right just like we would in an English class. So we would read this as H is greater than 50. So this would match this one. So when we look at this symbol in the middle, the open end is going to point towards what we say is bigger, and the pointed end is going to point to what we say is smaller. So we're saying that H is greater than 50. Now in B, we see that the arrow or the point is pointing towards the H. But we also see this single line underneath it. So when we see the point going to the left, we're saying that H is less than, but this little line underneath means or equal to. So this one is saying that H is less than or equal to 20. So that would match our top one. And then finally on C, we're saying 30. Notice the open end is to the 30, so we're saying 30 is greater than. And then we have this little line underneath, so we're saying 30 is greater than or equal to H. So that would match here with the bottom choice. Number 2, is 25 a solution to any of the inequalities? Which one or which ones? So if we read through these, is 25 greater than 50? No. Next, is 25 less than or equal to 20? No. Is 30 greater than or equal to 25? Yes. So that is the one that would be true because 30 is greater than or equal to 25. Next, is 40 a solution to any of the inequalities? So, is 40 greater than 50? No. Is 40 less than or equal to 20? No. And is 30 greater than or equal to 40? No. So this is not true for any of them. And finally, is 30 a solution to any of the inequalities? Is 30 greater than 50? No. Is 30 less than or equal to 20? No. Is 30 greater than or equal to 30? Yes, because 30 is equal to 30. So we could put this one down. 30 is greater than or equal to 30. So if you don't understand how I came to any of those answers, make sure you stop and ask me for clarification so that you can understand before we move on. How do you know whether each of the numbers 50, 20, and 30 is a solution to the inequality? So what we can do is substitute the number in for h and then see whether or not they work. Beyond the different symbols, how are these equations different from the inequalities in one variable? So when we have equations, we're saying the left side is equal to the right side. But when we're talking about inequalities, now we're saying it's less than, it's greater than, it's less than or equal to, and finally we could be saying it's greater than or equal to. So now, instead of saying the left and right sides are equal, we're saying that one side is larger than, smaller than, or equal to the right side. So now we have activity 18.2. This should take about 15 minutes. It's titled Planning the Senior Ball. Seniors in a student council of a high school are trying to come up with a budget for the senior ball. Here is some information they have gathered. Last year, 120 people attended. It was a success and is expected to be even bigger this year. Anywhere up to 200 people might attend. There needs to be at least one chaperone for every 20 students. The ticket price cannot exceed $20 per person. The revenue from ticket sales needs to cover the cost of the meals and entertainment, and also make a profit of at least $200 to be contributed to the school. Here are some inequalities the seniors wrote about the situation. Each letter stands for one quantity in the situation. Determine what is meant by each letter. So first we have T is less than 20. So if we look through these 4 bullet points, here at number 3, we see the ticket price cannot exceed $20 per person. So it could be less than, or it could be equal to 20. So this right here should actually say less than or equal to, and T equals ticket price. Next, we have 120 less than P less than 200. So in this first bullet point, we see that last year 120 people attended. It was a success and is expected to be even bigger this year. Anywhere up to 200 people might attend. So again, it could be as big as last year, which was 120. So this should say less than or equal to, and it's not going to be any bigger than 200, but it could be 200. So we would say less than or equal to 200. And that means P equals the number of people attending. Next, we have P times T. So we already know P is people attending. We already know T is the ticket price. So they're saying if we take the number of people attending and multiply that by the price of a ticket, and then we subtract M, it would be greater than 200. Well, if we look at this bottom bullet point, it says revenue from ticket sales needs to cover the cost of the meals and entertainment and also make a profit of at least $200. So it could be greater than 200 or equal to 200. It just couldn't be less than 200. And we're saying you multiply the number of people times the price of the ticket, and that needs to cover the cost of meals and entertainment. So this should say greater than or equal to, and M is going to be cost of meals and entertainment. And finally, we see that C is greater than P, which we said was the number of people attending, divided by 20. Well, the only one we haven't accounted for is the second bullet point. There needs to be at least, meaning greater than or equal to, one chaperone for every 20 students. So if we take the total number of people attending and we divide it by 20, our chaperones need to be greater than or equal to. So C is going to be the number of chaperones. So if you have trouble understanding how I came up with these, please take this time to stop me and ask for questions now so that I can give you clarification and so you'll be ready and on track for our next test. How many chaperones are needed if there are 120 students? Well, we said chaperones would have to be greater than or equal to the number of people divided by 20. So now we can say chaperones must be greater than or equal to 120 students divided by 20. So the chaperone number needs to be greater than or equal to 6. So there could be 6 chaperones, there could be more than 6 chaperones, but there could not be less than 6 chaperones. If you understand everything up to this point, please move forward. If you have any questions about anything I've covered so far, please stop me, ask your questions so that I can get clarification for you before we move on. Our next activity should take about 15 minutes. This is activity 18.3, titled Elevator Constraints. An elevator car in a skyscraper can hold at most 15 people. For safety reasons, each car can carry a maximum of 1,500 kilograms. On average, an adult weighs 70 kilograms and a child weighs 35 kilograms. Assume that each person carries 4 kilograms of gear with them. Number 1, write as many equations and inequalities as you can think of to represent the constraints in this situation. Be sure to specify the meaning of any letters that you use. Avoid using the letters Z, M, or G. So when we want to write as many equations and inequalities as we can think of, let's look at our information. An elevator car in a skyscraper can hold at most 15 people. So we could say that P is less than or equal to 15. The number of people in the elevator car can be 15. It can be less than 15, but it cannot be more. For safety reasons, each car can carry a maximum of 1,500 kilograms. So we could say that weight must be less than or equal to 1,500. It could be less than 1,500 kilograms. It could be exactly 1,500 kilograms, but it cannot be more than. That's what a maximum means. On average, an adult weighs 70 kilograms, and we have to assume that each person carries 4 kilograms of gear with them. So we could say that every adult is going to equal 74. The 70 kilograms per adult plus the 4 kilograms of gear they would have. And children would be 35, but they're going to have 4 kilograms of gear with them. So instead of 35, we want to say 39. So now what we could do is come up with an equation where our total weight is going to be the weight of adults plus children. So 74 kilograms times the number of adults plus 39 kilograms times the number of children must be less than or equal to 1,500. So we have an inequality for the number of people in the elevator car. We have an inequality for the total weight. We have an equality for the weight of an adult, an equality for the weight of each child, and we have an inequality that takes the weight of all the adults, adds it to the weight of all the children, and the total weight must be less than or equal to 1,500 kilograms. These would be the equations and inequalities that we would use. If you're in class, trade your work with a partner and read each other's equations and inequalities. Explain to your partner what you think their statements mean and listen to their explanation of yours. Make adjustments to your equations and inequalities so that they are communicated more clearly. So I've written down all the ones I could think of on the spot. You take any that you came up with, let your partner read them, read any that your partner came up with, and make sure they are as clear as can be. Rewrite your equations and inequalities so that they would work for a different building where an elevator car can hold at most Z people. So we said that P was less than or equal to 15. Well, now instead of 15, we're going to say Z because we don't know how many people. Each car can carry a maximum of M kilograms. So we said that weight had to be less than or equal to 1,500. Now we're going to say weight must be less than or equal to M. And we said each person carries G kilograms of gear. So that could be adults were 70 plus G equals the weight of adults. Or better yet, we could put this in parentheses and just multiply it by the number of adults plus 35 kilograms per child plus G kilograms of gear for every child. And now that needs to be less than or equal to M. So these could be the equations and inequalities that would work for this other building. So now we have our lesson synthesis. What are some advantages and disadvantages of representing constraints as inequalities? So advantages are having a wider range of values. Now the left doesn't have to exactly equal the right. It needs to be less than, or it needs to be greater than, or it needs to be less than or equal to, or greater than or equal to. So there is more flexibility. However, this could also be a disadvantage because now we don't always have an exact value. Now we might run into vague values that we don't truly know. What advice would you give a student who might just be learning to write inequalities to represent constraints? What should they pay attention to? What are some potential sources of confusion or error they should look out for? So the first thing I would say is make sure you understand that if the arrow points to the left, this is less than. If the arrow points to the right, this is greater than. And if either one of those have a single line underneath them, this is or equal to. The point goes toward the number that is smaller. The open end goes toward the amount that is larger. So make sure you understand which symbol means what. And make sure you understand the difference between something being less than or greater than and something being equal to. Because that is going to play a big role in how we graph this stuff. And finally, our cool down should take you about 5 minutes. You can do it on Kitum. 18.4, titled Grape Constraints. Han has a budget of $25 to buy grapes. Write inequalities to represent the number of pounds of grapes that Han could buy in each situation. So, if grapes are $1.99 per pound, we can say 1.99p. If I have a budget, that is the most amount of money that I can spend. So when I buy something, it must be less than or equal to my budget. It cannot be more than my budget. Now they're going to change it from $1.99 per pound to $2.49 per pound. So that's the only part that needs to change. We can still use P for our pounds, and it would still have to be less than or equal to the budget. We cannot go over the budget. And finally, if it costs C dollars, we could say CP must be less than or equal to 25, because again, a budget is the maximum amount we can spend. So if you are comfortable with our learning target, you should be able to say comfortably, I can write inequalities that represent the constraints in a situation. That is what we did in this lesson. If you feel good about this, then you are right where you should be, and you can move forward with confidence. If you still have questions, please use class time to ask me about those. Make sure that you get a copy of the practice problems and try this extra practice. You want to make sure you understand how to do these problems, especially how to do these problems on your own for when our test comes up on December 1st.